So I talk today a little bit about our development and this latest status of our PTC film heater and material developments. So I must look a little bit to the time to keep the 15 minutes. Yes, so I think we have a long history in manufacturing heater materials. I think the most classical and most well-known heater material is a silver-based fired-on ink for defogger for the back windscreen of a car. So which is a heater on glass. The same works on ceramic. It's fired on. So here you see a table. What else we have been in? So then we have developed heaters on metal, on steel, on aluminum substrates. We have a high temperature, so based on polyimide chemistry. Then we also have flexible or stretchable heaters for fabrics or textiles, and the same technology, but thermoformed only once, is for the in-mold electronic. So which is shown on the bottom photo, where is a heater integrated in a headlamp. And then we have PTC carbon heaters for quite a while, but in the beginning we only had one, and then yes, we have a high number of requests, and then we started to develop more. And I want to talk only about this type of heater today, so the PTC carbon. So first of all, I think we must say some words about the theory and the physics behind it. So heaters can have every different kind of forms, printed on ceramics, can be in form of wires, textiles, film. There are plenty of things, but all work to the same principle. It's a Joule heating. So when current is flowing through a conductor or resistor, it's heating up due to the electrical resistance, and there is a Ohm's law behind it. So everyone learned it in the school, which is a voltage is equal the resistance multiplied by the current going through, and the power is the voltage multiplied by the current, which is giving the power is the supply voltage divided by the resistance. And then you have different possibilities. So the resistance is more or less constant depending on the temperature. That is for the resistance heater, for example, like the windscreen heater, so a silver-based one. And I say it's more or less so it's roughly constant. Every conductor is also changing a little bit the resistance, but as long as it's neglectable and not changing the properties, we consider it to be constant. Then we have also PTC resistors, which are linear and fired on, that are high precise fired on resistors, which are primarily used for temperature sensors, so to take the change of the resistance with the temperature, and then to interpret it which temperature you have. And then we have an exponential behavior for the PTC paste, and that we are using for self-regulating heaters. So, and you see on the diagram on the right-hand side, that is a typical behavior. So the resistance is increasing exponentially with the temperature. So when current is flowing through, it's heating up, and then the resistance is going up, and due to the Ohm's law, so the resistance is going exponentially high upwards, and that means the power is then going in the other direction. So the heating power is then going down with the temperature. And this effect is in the end giving an effect of self-regulation, so that it reaches in the wished case, I come to this later, an equilibrium temperature. So that is what we're aiming for.